Hi science students, so this is part 2 of our collecting data table and graph from our previous hot water cooling and cold water warming experiment where we were tracking the temperatures over 30 minutes. We have this data table that now we're going to put onto a graph. And what I did was I took a piece of graph paper, regular size graph paper, and I cut it in half so that this can stay in our science notebook. And what we're going to do is we're going to draw a graph with a y-axis and the x-axis. The x-axis will be time, so between 0 and 30 here, and then the y-axis will be temperature. And we're going to see how the hot water temperature changes over time, the cold water changes over time, and then of course room temperature, it looks like it stays steady. So what I've chosen is a black marker to draw our axes and our labels. Red for hot, blue for cold, and then a gray and a I guess a teal or blue-green color for the room temperature. So let's put these aside for now. I'm going to draw my axes. And I know it's kind of hard to see, but I'm going to try to use a straight edge too, so that I can stay neat. All right, and before I draw, I actually need to use the graph paper to help me count the number of squares that I might have available to me. So I do want to give myself some room to write the numbers and the titles here. And maybe I'll just start here, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, it looks like I have 24 squares that I can comfortably draw this line. And I have 30 minutes that I need to fit onto this line. So what I'm thinking is maybe I can do every 2 squares is 5 minutes. So I'll start with 0, and then 5, 10, 15, 20, 25, 30. Oh no, so that was too few squares, because from 0 to 30 I end up here, and that means my entire graph would have to fit in this space, and all of this would be blank. So maybe I think it'll be every 3 squares will be 5 minutes. So we'll start with 0 here. 1, 2, 3, 5, 10, 15, 20, 25, 30. Okay, I think that looks a little bit better, and so you can see it takes up definitely more space, but it doesn't go all the way to the end. How about we start here and compare? What if it was 4 squares? So every 5 minutes, it's actually 4 squares. So 0, 5, 10, 2, 3, 4, 15, 20, 25, 1, 2, 3, 30. Oh wow, so this is right at the end, right where the circle is. Yeah, I think I'm actually gonna risk it, or I can scoot over 1, and then I can use this rule. Every 4 squares, I'm just gonna put, I'm gonna mark it as 5 minutes. So I'll start here, and I'm gonna draw a line that goes across. So I'll start here. I'm gonna draw a line that goes all the way across. Okay. And so this is time in minutes. All right, so this is 0, 1, 2, 3, 4, 5, 1, 2, 3, 10, 1, 2, 3, 15, 1, 2, 3, 20, 1, 2, 3, 25, 1, 2, 3, 30. So every 5 minutes, we're gonna have a data point. Okay, then now from here all the way up, let's see how many squares we have and what our range of temperatures needs to be. Okay, so our range of temperatures, our highest temperature that we see is 81, and the lowest temperature that we see is 8. So on our graph, it needs to go, I'm guessing, from 0 to at least 80, or maybe 90. So we'll say maybe every 2 squares is 10 degrees. Maybe we'll start with that. Okay, so 0, 10, 20, 30, 40, 50, 60, 70, 80, and maybe one more square is 85. So we'll just add just that little bit left. Now, if you have different graph paper, then your squares might be a different size, or if you maybe were able to cut out a little bit more or shift your axis a little bit to the left or up or down, then you might have more space. But for me, the way I have my graph paper here and the way I'm drawing my axes, I do want all of my data to fit neatly onto this graph paper. I don't want my graph to be too small, or of course, if it's too big, the data won't fit on the paper. So if this is 0, this is 10, 20, 30, 40, 50, 60, 70, 80. And this will be temperature in degrees Celsius. Okay. All right, now, if you want to use color pencil or regular pencil to start off and then fill it in with marker, that's fine. But right now, I'm going to start to graph. So starting at time t equals 0, my hot temperature was 81. So we started at 81 all the way up here. And then 5 minutes later, it went all the way down to 55. So at 5, we go here. Then at 10 minutes, it was 43. This is 42.5, so 43 is somewhere up here. Then 37 at 15 minutes. 35. Oh no, this was 45. So 43 is actually, oh no, I've made a mistake. Okay, well, I'll put a little dot here. My mistake. So this little line here is 45 because it's in the middle between 50 and 40. So 43 is actually this little dot here. And then 37 is a little bit above 35. So 37 is right here. At 20 minutes is 33, which is a little bit below the 35 mark here. At 25, it was 30 on the dot. And then at 30 minutes, it was 28, a little bit under 30. Okay? And you can already see, we're going to connect it with the line soon, but you can already see that this starts to slow down in terms of its change in temperature. So in 5 minutes, it changed over 20 degrees, and then the next 5 minutes, it changed more than 10 degrees, and then after that, the change in temperature started to decrease. Okay, so while I still have my red marker out, I'm going to use my ruler and connect the dots. Okay, and you can correct any mistakes. Later, another lesson will be graphing it on the computer. And on the computer, anytime you make a mistake, you can always undo it or redo it, right? With markers, especially permanent markers that I'm using, it's a lot more difficult. So maybe I'll put like a little X here because that was a mistake. Okay, the next one is cold. So for cold water, I'm starting with, we'll use blue. We're starting at time t equals 0. Hot is, cold is at 8, so 8 degrees. This is 5, 6, 7, 8. 8 is somewhere right here. 5 minutes later, it was at 11. 10 minutes, it was at 13. 13 is a little bit less than 15, so we'll put it right here. At 15 minutes, it was 15, which is here. At 20 minutes, it stayed at 15. At 25 minutes, it was 16, which is slightly above. At 30 minutes, it was slightly above 16 at 17. It looks kind of flat, right? But there is still this change. It started at 8, and then it went up. And then it ever slightly went up. And it stayed where it was. It stayed where it was at. And then went up again slightly. And again slightly. Okay, and then it's, oh, and you should be careful. My markers are bleeding through the back of the paper onto the bottom paper. So if you're working on a sensitive surface, or if you're working in your science notebook, just be careful that the pages, especially using these permanent markers, they're quite inky and they can bleed through. All right, so room temperature, and so the room temperature water and the room temperature, as in the air in the room, they both stayed at 21 degrees the entire time. So that's why I'm just using one marker, and 21 is somewhere around here. And I'll just go all the way across, and it doesn't really change, right? The number 21 doesn't change throughout the whole 30 minutes. I'll use another ruler line. Okay, and now that we've graphed it, it does look like there is some kind of trend, right? Will the hot water always forever be decreasing? Will the hot water eventually go down to 0? Maybe not according to this graph, right? We see that the way it's converging, these lines are converging towards a center number. So that's why it's important to see the data in a graph so we can visualize and use this data and see the trends so that we can predict what the behavior is going to be in the future. Okay? And so the last finishing touches we have is a title, and we'll call this water temperature graph over time. Let's just say that. And then usually there's a reference or a legend where we'll say this is, for the red line, it's going to be hot water. For the blue line, it'll be cold water. And then for the blue-green line, we'll say this is room temp. All right, so this is our data table. We would actually, the plan is to neatly copy this data table into our science notebook. And now that we have this graph, we would neatly tape or glue our graph into the proper page in our science notebook. So maybe you would take this data table and write it in here, and then on the other side you would have your graph. Let's see, I haven't put it in my table of contents yet, but along with your reading notes and your safety self-portrait, you would have a data table and a graph. Okay, so what we did just now was we took this data table that we collected data in our activity on hot water and cold water. Hot water was cooling down. You can see the temperature lowering. The cold water was slightly warming up, and then the room temperature stayed steady. So now we can visualize the data table in a graph. Okay, thanks for watching.